Johannes Kepler was a German astronomer active in the 16th and 17th centuries. While conducting research on the orbital motion of planets, Kepler discovered that planets in the solar system follow common rules. As a result, Kepler's 3 celestial laws were born. Kepler's first astronomical law is that the orbit of a planet is an ellipse centered on the Sun. This disproves the theory that conventional astronomers argued that the orbit of a planet is a perfect circle. Kepler's second celestial law is that the planet travels at a constant speed from its origin centered on the Sun. This means that the speed of the planet is constant in other locations in its orbit. Finally, Kepler's third celestial law states that the square of a planet's orbital period is necessarily proportional to the cube of its average distance from the Sun. This law represents the relationship between the distances between planets and the orbital period, and it has been proven that all planets in the solar system follow this law. Kepler's laws of celestial bodies played an important role in developing an understanding of the motion of the solar system and the universe, and also had a significant impact on the development of modern astronomy. Johannes Kepler's laws of the heavens can be expressed by the following formula. The first law, form of orbit. The orbit of a planet is an ellipse centered on the Sun. If the radius of an ellipse is a and b, the flatness of the ellipse can be expressed as E equals sqrt, 1, b squared, a squared. At this point, E has a value between 0 and 1, where 0 approaches a complete circle, and as we approach 1, the shape of the ellipse becomes clear. The second law, rotation of the plane. The planet travels at a constant speed from its origin around the Sun. When we say the speed of the planet is v, the distance to the Sun is r, and the mass is m, the second law can be expressed by the following formula. F equals ma equals mv squared, r, where F represents the gravitational force, and a represents the acceleration. Therefore, v squared, r is a constant, which has the same value at all locations. This is one of the key principles of the second law, which shows that the planet travels at a constant speed. Third law, orbit cycle. The square of a planet's orbital period is necessarily proportional to the cube of its average distance from the Sun. If the average distance of a planet is r and the orbital period is t, the third law can be expressed by the following formula. T squared equals 4 pi squared, gm, r cubed, where g represents the universal gravitational constant and m represents the mass of the Sun. This equation shows that all planets in the solar system follow the third law. It can also be used to predict the motion of other celestial bodies outside the solar system.